Good morning, everyone. Myself, Janaki, working as a assistant professor in Tigala Reddy Engineering College. My subject name is Environmental Science. My top today I discuss about the topic name is Ecological Pyramids. Okay, first of all, what is ecological pyramids? The idea of ecological pyramids was first of all given by Charles Elton in 1972. Ecological pyramids are also known as Eltonian pyramids. Okay, who is proposed name Charles Elton. That's why another name is ecological pyramid, another name is Eltonian pyramids. Next one, definition of the ecological pyramids: the graphical representation of number, biomass and stored energy of various trophical level of food chain in an ecosystem is called ecological pyramids. Okay, see this shape is first one. Seeing, okay, this is the vertical pyramid shape. This is the inverted pyramid shape. This is vertical. This is the inverted. C is the upright pyramid shape and inverted pyramid shape. First one is the this is a producer consumer levels is there, food chain levels is having here. The concept of ecological pyramids was derived by British ecologist Charles Elton in 1972. Okay, the trophic level in an ecosystem may be defined as a position occupied by a living organisms in a food chain. Okay, the relationship among the successive tropical levels of food chain terms of the number. Okay, biomass and pyramids of numbers, pyramids of biomass, pyramids of energy. Okay, energy nothing but stored. Content may be represented by means of graphical diagram, and this graphical representation is called ecological pyramid or food pyramid. Okay. Once again, see here the graphical representation of the number, biomass, and stored energy of the various trophical levels of the food chain in an ecosystem is called ecological pyramids. The types of ecological pyramids, see the types: pyramids of numbers, pyramids of biomass, pyramids of energy are stored. First one, I discuss about the first one, first type of pyramid of number. First type of the pyramid of number. Okay, pyramid of number. This pyramid shows the relationship between producers and consumers of different trophic levels in terms of their numbers. Okay, this pyramid shows the relationship between producer and consumers. Okay, see the grassland ecosystem, for example, is denotes the relationship between population and density of organisms in food chain. Populations of density organisms of the food chain. In a grassland ecosystem, see here, in a grassland ecosystem, pyramids of numbers is upright. Pyramids of numbers, there are two types: upright pyramids of numbers, inverted pyramids of numbers. Okay, upright pyramids of numbers, if the size of producers is very small in comparison to the size of consumers, the pyramids of numbers is upright. See the diagram in crop field. In crop food chain, crop, insects, frog, snake, hawk. First one, crop eaten by insects, insects eaten by frog, frog eaten by snake, snake eaten by hawk. This diagram shape, total shape is upright pyramids. Nothing but vertical shape. This is the quaternary consumers, tertiary consumers, secondary consumers, primary consumers, producers. Producers eaten by primary consumers, secondary consumers, tertiary consumers, quaternary or top consumers. Okay, upright pyramids of numbers is the size of producers in very small in comparison to the size of consumers. Okay, see this in Croftfield diagram. Next one, inverted pyramid of numbers is the Forest ecosystem, the inverted pyramid of number is formed because the number of trees is less, the number of consumers is more, but their size is small. Is see here, this is a different. Here also different. So tree, birds, insects. This is the inverted shape. Okay, producers eaten by consumers, consumers eaten by parasites. Okay, na? This one next. Pyramid of biomass. Next type is, for example, see the pond ecosystem. Pyramid of number upright with largest number of the producers. The photoplanktons at the base supporting less number of primary consumers, lesser number of secondary consumers, large fishes and the least number of the tertiary consumers. Okay, this is the pyramids of numbers. Pyramids of numbers. Second type is pyramid of biomass. In the biomass is maximum at base because the number of organisms decrease as we proceed towards apex. For example, see the state pyramid of biomass. State pyramid of biomass. Terrestrial ecosystem example, terrestrial ecosystem food chain example, tree eaten by birds, birds eaten by the insects. Okay, producers, the tree is the producer, birds is the primary consumer, insects is the parasitic. Okay, tropical level 1, tropical level 2, tropical level 3. This is a state pyramid of the biomass. Next one, inverted pyramid of biomass. Here, secondary consumers, large fishes, herbivores. See the aquatic ecosystem. Shape is the herbivores. Here, large fishes. Secondary consumers, primary consumers, diatoms, phytoplanktons. Phytoplanktons is the producer. Okay. Tropical level 1, tropical level 2. This is the aquatic ecosystem example. Next, third type is okay. Third type is pyramid of biomass. The pyramid which show the energy accumulation by organisms of different tropical levels is called pyramid of energy. This is always upright only. Okay, always the consumers primary, secondary, tertiary of each tropic level of food chain utilize 90% of energy obtained by food material in respiration, store only remaining 10% energy. See the producer characterized by the maximum energy. Energy at each successive level of consumers goes on decreasing. Okay, consumers level is decreasing. That is where the pyramid of energy is always upright. Okay, this is different. Pyramid of number, pyramid of biomass, pyramid of energy. Okay. Next, see here, energy at each successive level of consumers goes on decreasing. That is where the pyramid of energy is always upright. See the diagram. Produces 100 calories eaten by 10 calories of primary consumers, 1 calories secondary consumers and tertiary consumers. See the 1000 calories, 100 calories, take any number of calories. Per here, producer is the more taken the more calories. Okay. Next one. These are three types of pyramids, ecological pyramids, pyramids of numbers, pyramids of biomass, pyramids of energy. See this picture. Ecological pyramid are of these types. Pyramid of number, pyramid of biomass, pyramid of energy. Pyramid of number can be upright and inverted only. Here biomass also can be upright or inverted only. Pyramid of energy always upright. Pyramid of numbers, see the upright, For example, grassland, land, inverted forest, pyramids of biomass, upright terrestrial ecosystem, and inverted is the aquatic ecosystem. Take any examples. Pyramid of energy, always upright. The energy transfer happen in a word. Okay, with the law given by Lindman. Okay, 10% law which states that only 10% of energy is transferred from one tropic level to another tropic level. Example, sun, mage, rodents, snake. Sun here, 10,000 joules, okay, 1,000 joules, 100 joules, 10 joules. Calculation for the 10% of the 10,000, 10 by 100 into 10,000, nothing but 1,000 joularies. Okay, next. Okay, limitation of the ecological pyramids. More than one species may occupy multiple trophic levels or in case of the food web. Okay, this is the system does not taken into account food webs are applicable only to simple food chain which usually do not occur naturally. The saprophytes and decomposers are not considered in any of the pyramid, even though they from an important part of the pyramids, even though them, okay, from an important part of the various ecosystem. Saprophytes and decomposers consider the various ecosystems. The pyramids do not deliver any concept in relation to variations in the season and climate. For example, see the example grass. Grass eaten by the grasshopper eaten by the frog eaten by snake eaten by hawk. See the diagram, hawk. See grass eaten by bird eaten by snake eaten by the hawk. Okay, grass eaten by rabbit eaten by the hawk. This is an example. Next, significance and importance of the ecological pyramids. Produce, Producers from the base of pyramid, and this indicates the importance of producers. More than a number of producers and biomass stronger will be ecosystem. Biomass stronger will be ecosystem. Flow of energy in an ecosystem in unidirectional was follow law of thermodynamics. Unidirectional and follow law of thermodynamics. Ecological pyramids show the trophic levels are device organisms in a different ecosystem. Okay, any disturb in trophic levels may result in collapse of pyramid and thereby entire ecosystem. This is the significance importance of the ecological pyramids. Okay, unidirectional and thermodynamics. Next topic is ecological successions. Okay, definition of the ecological successions, types of, we are discussing about the definition of ecological succession, types of ecological successions, hydrosphere and lithosphere. Okay, for first one, definition of ecological succession. The occurrence of relatively defined sequence of community over a long period of time in the some area, resulting in establishment of stable or climax community is called ecological successions. Okay, occurrence of relatively different sequence of community, definite sequence of community, a long period of time. Okay, long period of the take the time. Okay, this is the called ecological successions. There are three communities. First one, pioneer community, transitional or serial community, climax or stable community. First one, I discuss the first type, pioneer community. Pioneer community. The first community to inhabit on area is called pioneer community. And the area not started anything. Okay, only first starting in the pioneer community. Okay, next one, transitional community, the intermediate community between pioneer and climax community. Pioneer community, see the transitional community, and climax community. First pioneer community comes, next transitional community, next come climax and stable community. Stable community nothing but last stage. Okay, last. Next fixed the community. Next third one, climax stable community. The last and stable community is an area is called climax stable community. Not changing the year any communities, only one stable community is having. Okay. Next one, types of succession. Primary successions, secondary successions, autogenic successions, allogenic succession. We are having four types of successions. First of all, I discuss now first type, primary successions. An area where there was no previously any sort of living matter here. First group of plants establishing there are known as the pioneer. On area, land is formed by volcanic lava, newly formed estraline node, bank or glaciated surface. Primary successions takes longer period, time-taking process. Here, longer period means a time-taking process. An area where there were no previously any sort of living matters. First group of lands establishing there are known as the pioneer. Next one, secondary successions. An area which the existing community. Then sudden changes. You're having sudden changes in climatic factors, biotic intervention and fire, etc. Biotic interventions and fire, etc. Existing community disappear. Existing community disappear. Here now the substratum with organic matter but divide of living matter. Now the secondary succession starts. Okay, secondary succession started in the sudden changes here, climatic factors or any changes, physical factors, sudden changes having secondary successions. In a third type is autogenic successions. Autogenic successions. Autogenic, an area with already existing community, already existing community, interaction of existing community with its environment results in changing its own environment, causing its own replacement by new community, own replacement, own changes by new community. Okay, own environment and new community. This is the autogenic successions. Next, fourth one, last type, allogenic successions. Replacement of existing community caused by largely by any other external conditions and not by the existing vegetation itself. A vegetation itself, we are having external conditions. Existing community caused by the largely by any other external condition. This is called allogenic successions. Next, general process of ecological successions. General process of ecological successions. General process of ecological successions. Here, first one, nudation. Nudation. It involves the development of a bare area. Okay, bare area without any form of life. Bare area, without any area form of a life. Invasion. Second one, invasion. It involves the successful establishment of a species in a base area. Okay. Migration, dispersal. It involves reaching of seed, spores, etc. Bare area through water, air, etc. Migration, dispersal. Okay, ecosis. We're having ecosis. In invasions, first one is migration, ecosis, Aggregation. Ecosys is the establishment. It involves the successful adjustment of a species with the prevailing conditions of that area. Prevailing conditions of the area. Aggregation. It involves the increase in the number of organisms through the process of reproduction. Number of organisms through the process of the reproduction. Reproduction. This is called aggregation. Next, third one, competition. It involves the intraspecific and interspecific competition for food and space. Reaction, next one, reaction. It involves the modifications of environment. Modification of the environmental is the reaction. Modifications area becomes less favorable for existing community. The old transitional community are replace one another in that area. Okay, in that area. This is the reaction. Next, stabilization. Stabilization is but climax. In this, the final community becomes stable community. This final community maintain itself with the climax of that area. This final community is called stable or climax community, and the final stage is called climax stage. Second type, hydroseed. Hydroseed. We discuss it now. Hydroseed. Hydroseed involves the ecological successions in the newly formed pond, lake. Newly formed pond or lakes, anyway. Stages in hydroseed, plankton stage, rooted submerged stage, rooted floating stage, reed swamp stage, sedge meadow stage, woodland stage, forest stage. We are having stages of hydrosphere. First stage is the plankton stage. See this diagram. This one is the water, trees having, this is the atmosphere, okay, environment. See the first one, this tree is the phytoplanktons. Next one, rooted, submerged, floating, okay, reed swamp, marsh meadow. Next, wood levels, climax forest. See first one, the plankton stage. See, it is the pioneer community of the hydroseed, and it is formed by the gamination of in crystal species. In crystal species, these all are crystals. Okay, water and crystal rocks also having the in crystal species. See, the population of phytoplanktons are regulated by the zooplanktons. Phytoplanktons death after organic matter producers after form mud at the bottom of land after favorable growth of net stage. Okay, environment stage. This is the phytoplanktons. Phytoplanktons, pioneer community of the hydros. It is formed the combination of crystal species. Combination of the crystal species. Population of the phytoplanktons regulated by the zooplanktons. Regulated of the zooplanktons. Next, rooted submerged stage. See here, this stage is formed of rooted submerged hydrophytes like Hydrilla valencianaria, etc. Hydrilla, example, rooted submerged. See this picture. Next, dead decay of these plants and sand deposit at the bottom of the pond. In pond, dead decays, dead tree, this one. Okay, bottom level of pond increasing stage. Okay, favorable growth of next stage. After pond increasing the stage. Okay, bottom level of the increasing stage. See this. Bottom level increasing. See here. This is a dead, okay, rooted submerged stage. Next one, rooted floating stage. See this rooted floating stage where this is the rooted floating stage in upper also coming in flower, okay, leaves. Rooted, this stage is formed of rooted floating and free floating hydrophytes. Okay, hydrophytes. Okay, reed spam stage. See this reed spam stage. Reed spam stage. See this picture here growing leaves also, developing the trees. Reed spam stage, it is also called amphibious stage. as most part of the rooted plants remain exposed to air. Example, typha. Okay, example, typha. Next one, stage, meadow stage. It is mainly formed of plant species like care, like carex and herbs like polygonum, etc. They form like negations towards the center of the pond. This develop the marley conditions. See this sage meadow stage mainly forward of plant species. Plant species, sedge meadow stage, this one marsh meadow stage. Okay, next one, woodland stage. In this stage, the peripheral part of the plant is involved by some shrubby plants. This can tolerate bright sunlight as well as water logged conditions. Okay, next these further lower the water table by their transpiration and build up more soil. See, is correct? Yes. Woodland. See this. Okay. Soil. Forming the soil in the develop the tree. Okay. Woodland. Climax. Last one is the forest stage. It is the climax community. It depends upon the climatic conditions. Okay. Next here, moderate rainfall and decay rainfalls. Tropical deciduous forest in a tropical rainforest, temperature region, mild mirate forest. Okay, temperature regions, tropical rains and temperature regions, decay rainfalls. Next, energy flow. This is the ecological, total ecological successions. See this one, types. Okay, hydrocene, also plant, plankton stages, rooted, submerged. This is our woodland stage, forest stage, develop the tree also. Yes, coming. Next one, energy flow in ecosystem. The existence of flora and fauna in ecosystem depends upon the cycle of mineral and flow of energy. See this energy needed for all the biotic activities. Sun, only source of the energy. Sun is the only source of the energy needed for all the biotic activities. Biotic means and living organisms. Okay, sun produces, the sun taken the produces plants. Okay, produces taken by herbivores. Herbivores is the secondary consumers. Secondary consumers the tertiary consumers. Energy flow. See energy flow one to another person. Sun taken by the producers. Producers means plants. Plants of the primary consumers. Plants taken the energy. Secondary consumers. Secondary consumers taken by the energy. Tertiary consumers. After last, the decomposers. Decomposers. After death, here coming the energy. Heat release. Okay. Heat releases. See this decompose secondary consumers also coming take the decomposers, and herbivores also taken the decomposers, and plants also taken the decomposers. Okay, this is the last the decomposers. Okay, energy flow movement. See this energy, sun produces herbivores, secondary, tertiary. For example, see sun taken the grass eaten by the grasshopper eaten by the rat eaten by the snake. This is the final. Okay, next the extends transformation and diffusion of energy in ecosystem are governed by laws of thermodynamics. Already ecological successions also coming this one, thermodynamics. Thermodynamics, there are two laws. First law of thermodynamics. According to this law, energy can be transformed from one form into another. It can neither be created nor destroyed. Okay. First law of thermodynamics. Transform. The energy can be transferred from one from to another. Okay. This is the first law of thermodynamics. Secondary law of thermodynamics. According to this law, during the process of transformation of energy, some of the transformed energy is diffused from the ecosystem, is dispersed from. Okay, thermodynamics. According to the law, during the process of transformation of energy, some of the transformed energy diffused from the ecosystem is dispersed from. Okay, next, see this 10% law of energy. 10% law of energy. See, first one, sun. Sun taking some energy, plants. Plants take the energy, herbivores. Herbivores taken by energy, carnivores. Carnivores are taken by energy, top carnivores. See here, sun. Okay, next, plants in taking the calories, 1,000 calories. Here, 100 calories. Here, see 10 calories available as food. Okay, 1 calories available as food. Here having only one. Last stage. 990 calories lost to the environment. Okay, once take the energy at the time, loss also energy. Some percentage of energy also loss. For example, human beings take the oxygen and lost the energy in carbon dioxide. Okay, here 100% or 10% loss, giving and losing. Okay, taken and lasting also. Okay, next, here 90 calories lost of the environment, herbivores. Carnivores, 9 calories lost to the environment. Okay, next, this is the 10% law of the energy. Next, Lindman gave the 10% law in 1942. This law states that only 10% of energy in a food chain out of the total energy is transfers from one trophic level to another trophic level. Lindman given the 10% law in 1942, year of 1942. The law states the 10% of energy food chain out of the total energy is transformed from one trophic level to another level. In human beings also take the oxygen in the energy, food, any food, food, fruits or food, anything. After the releasing water, okay, some energy also lagging. This is end of the section. Thank you, everyone.